Let's talk chemistry with Pastor Dan. We're looking at the last of the gas laws that we're going to look in this section. It's referred to an ideal gas law, which means it's a gas law performing, behaving in a perfect or ideal manner. Now, we talked about the different gas laws we've had so far. We have the combined gas law, and that's Boyle's law, Charles' law, and Gay-Lussac's law. So whenever we have two sets of conditions, two temperatures, two pressures, two volumes, that's when we use that one. Then we talk about the Dalton's law. Dalton's law deals with partial pressure, so the collecting all the volumes, or when you're collecting over water. Those are two ways we do those. And then Graham's law deals with diffusion. That's the ratios always. So we come to the ideal gas law. Gas law, the way to identify it, the way to make sure you know what it is there's one set of conditions. One temperature, one pressure, one volume, one mass, one molecular weight, anything along those lines. So that's how we know what we're talking about. Now, when we deal with the combined gas law, we're going to take our values, our combined gas law, PV over NT, where N is another value we're going to find. It's called the number of moles. It has to actually it is a gas law as well, referred to as Avogadro's law. It's not necessarily as well known as the other ones. And if we put those together, we get a value R. Now, R stands for the ideal gas constant. It's going to be infinitely significant. There's two sets of values here. It's either going to be 0.0821 liters atmospheres over moles Kelvin, or it's going to be 8.31 liters kilopascals per mole Kelvin. So how do we know which one we're going to use? Well, if we're in atmospheres, we use this one. If we're in kilopascals, we're going to use this one. What do we do if we're in bars or millibars or torr, millimeters of mercury? We convert it to atmospheres or kilopascals. That's the easy way to do it. Now, the equation then, if we solve up and get rid of that fraction, is PV equals nRT. My old high school chemistry teacher used to call it Pivner. PV equals nRT. All right, so let's take a little problem. Find the volume of 1.289 moles of gas, just any gas, at 75.9 degrees Celsius and 1.0876 atmospheres. Again, there's only one set of conditions. So we know this is not combined. We're not talking about partial pressures. We're not talking about diffusion. We know this is ideal gas equation. Yes. So our equation, PV equals nRT. Let's do our values. PV, nR, and T. Well, P is 1.0876 atmospheres. V is unknown. That's what we're looking for. Find the volume. N is number of moles. So it's 1.289 moles. R is our gas constant. Now, which are we going to use? Well, I'm in atmospheres. So I'm going to use 0.0821 liters atmospheres per mole Kelvin. And the temperature is 75.9 degrees Celsius. But remember, we don't like Celsius because it's 0. So convert that to Kelvin, add 273. I'm going to get 348.9. So if I'm solving for V, write the other side down, as is where is nRT. P is going to come down. So we're going to get V is equal to nRT over P. Put our values in. So we're going to get 1.289 moles times 0.0821 liters atmospheres per mole Kelvin times 348.9 Kelvin. Hit equal on your calculator and then divide that by 1.0876. And when we do that, our moles cross out, our atmospheres cross out, our Kelvins cross out. We're left with one value, that liters, multiply through, you should get 33.95 liters. All right, now we can't be limited to just this one equation. So if we take our ideal gas equation and think about it, well, what would you use more often than moles? Well, often the moles is equal to mass divided by molecular weight, right? So we plug that in and solve out, get rid of the fraction, we end up with the second equation, PVMW is equal to MRT, where MW is molecular weight and M is mass. So let's try another problem. Calculate the mass of 13.55 liters of carbon dioxide gas at 100.8 kilopascals rather, and 23.9 degrees Celsius. So we use this equation since we're dealing with mass, okay? We use the first one to have moles, we use one with the mass. So our graphic organizer here, PV, MW, MRT. P is whoa, we hit the wrong button. 100.8 kilopascals, and V is 13.55 liters. Now, molecular weight, for that, we'll look at carbon dioxide. Remember, that's a covalent molecule, CO2, carbon is 12, oxygen is 16 times 2, 32. Using the periodic chart here, 16 times 2, 32 plus 12, we get 44 grams per mole is the molecular weight. Mass, we listed in there, is what we're looking for actually, so that's my question mark. And then R, we're going to use the constant 8.31 because we're in kilopascals. Temperature again is 23.9, but we don't like Celsius. We're going to add 273 and get 306.9. So we're solving for mass. What's the opposite side of mass? PVMW. So write that down. That means R and T are going to have to come down. So we're going to get M is equal to PVMW or RT. Plug our values in. We get 100.8 kilopascals, 13.55 liters, 44 grams per mole. Hit equal in the calculator. Divide by 8.31. Hit equal. Divide by 296.9. Calculator. Hit equal. When we do that, what units cross out? My kilopascals cross out. My liters cross out. My moles cross out. I'm left with units of grams. Plug in the calculator. Should get 24.36 grams. All right. Now, one more equation we can use. Take our second ideal gas. Remember, we use the first one if we have mass. First one if we have moles. Second one if we have mass. Now, can I do anything with this? Well, I've got a V and an M here. Is there an equation that we talked about involving mass and volume? Hopefully you remember density. So if I move volume over, rearrange the equation, I can make my equation PMW is equal to DRT. So that's my last ideal gas equation. All right, here we go, because of density. Here we go. So we want to identify the density of nitrogen dioxide at 755.8 torr and 32.9 degrees Celsius. My values here, I have 755.8 torr, and I have 46 because that's NO2, nitrogen dioxide, nitrogen, periodic chart, 14, oxygen, 16 times 2, 32, 32 and 14, 46. We're going to have unknown density, and my 305 because I take 332.9. Now I do need to convert that torr into either atmospheres or kilopascals. Let's do atmospheres because it's easier. So divide by 760. I have 4 sig figs. Use your calculator. You should get 9.9945 atmospheres. Which R we're doing? Well, for an atmospheres, we're of course going to use 0.0821. We're solving for density. Opposite across for density is still PMW. We're going to move the RT down. So we're going to get PMW over RT. Put our values in. 0.9945 atmospheres times 46 grams per mole. Hit equal in the calculator. Divide by 0.0821. Hit equal in the calculator. 305.9. One last time. And we get, when we cross all our units out, 1.822 grams per liter. So that's the process. All right, so pause the video. The first one deals with mass, so you can use the second one. Second one gives us moles, so you can do the first one. Pause it, try it, see what we come up with. Here we go. So when we use the equation, we're using PV equal MRT. So M is PV MW over RT. Put our values in. Answer is 26.543 grams. For our second one here, we're going to use the PV equals nRT, Pivnert, solving for V, nRT over P. Put our values in, 42.55 liters. Hopefully that wasn't too bad. Take care. God bless. Bye.